Hello and welcome. This lesson is on non-renewable resources. Get ready to learn. We got some coal burning. Once this coal burns up, it's gone. Did you know energy provides the ability to move or change matter? This is the definition of energy. So energy allows us to move or change matter. Now we get our energy for life from food, the food we eat. And here we got some wood being burned and going in, heating some food that we eat. So the energy is in a whole bunch of different forms. Now, energy comes in two major categories. It's either renewable, can be replaced, or non-renewable. Once we use it, it's gone. Now, non-renewable energy is not replaced in a lifetime. While coal is still being made, it takes millions of years. So we have two major categories. It's either renewable or non-renewable. And the difference is non-renewable cannot be replaced in a person's lifetime, 7,500 years. Most energy used today is non-renewable. So it's going to be used up. Now, while we're working on using renewable energy, we can make efforts to conserve what we're using now, not use as much, or use only what you need. Conserve comes from the same idea as to hold back. So, why is this important? Well, most of our energy comes from non-renewable resources. We need to understand how to make them, the non-renewable resources, last longer and use them wisely. Because once they're gone, they're gone. And energy is becoming more and more expensive the harder it is to get. What is important to know about non-renewable resources? Well, there are two groups. We have the renewable resources like hydropower. Falling water turns a generator, makes electricity. Solar. You can either make electricity directly from solar cells, or you can heat water a couple different ways. Biomass. You can grow trees, cut them down, and then burn them. Wind. Use the wind to turn turbines, propellers in the air. And geothermal. Using the energy of the earth. Now, we also have non-renewable resources. Fossil fuels like coal, see coal here, oil, natural gas, and nuclear. You might ask where gasoline is, and here it is in oil. Oil comes out and is broken or cracked into different types of liquids. One of them is oil. The other is diesel fuel, gasoline. The natural gas is a gas itself, not a liquid like gasoline. Okay, our primary energy resources or energy sources are non-renewable. So we have a chart here. Let's break it down. These things take millions of years to form. Natural gas, petroleum, coal, nuclear, hydroelectricity, and other renewables. This is the share by fuel in 2015. So this is our whole fuel consumption here. Let's look at the non-renewable. Natural gas, 24%. Petroleum, oil, gasoline, 33%. Coal, 30%. And nuclear is 4%. Now, if you add all that up, it comes to 91% of our energy sources is non-renewable. Now, that was in 2015. Today, it's slightly different, but not a lot. What's important to know about non-renewable resources? Well, hydrocarbons, fossil fuels. These are things that were once alive. Coal, oil, natural gas. Again, gasoline for your car is in this oil. So we have coal, we have oil pumped out of the ground, coal is dug out of the ground, and natural gas, you put a pipe down and push it out. Now, coal. Coal at one time was once living material. Plants, animal, yes, dinosaurs. Over the years, all this material, leaves and trees and animals, fell to the ground. And the first thing it made was something called peat. And peat is you can cut it out of the ground. Think heavy grass. You can cut it out of the ground and it actually burns. Now, over time, this stuff just keeps piling up and piling up and piling up over millions of years. Heat and pressure squeeze the water out, squeeze the material together, compress all this living material at one time into something called lignite. That is better than peat to burn, but still doesn't burn well. Heat and pressure on lignite turns it into coal. So over time, it goes from peat to lignite to coal. And coal burns very well. It's got a lot of energy stored up in it. Now, as you can imagine, all this material here is squashed down with heat and pressure to compress it, to condense it. Now, it takes millions of years to do this. Once we burn it, it's gone. Yes, it's still being done today, but not many people can wait around 1,000,000 years for it to finish. Now, oil and natural gas are a similar kind of process happens. In the ocean, marine animals fall to the bottom when they die. Sediment and rock, gravel, pieces of dirt. You settle on top of it, squeeze it, and organisms turn into oil and gas over time. So 300 to 400 million years ago, it looked like this. 50 to 100 million years ago, it had started being squeezed squeezed between layers of rock. And today, we drill a hole down, we get into an area where there's trapped gas and trapped oil. Oil and gas hang around together. And if we drill a hole down, we can pump it out and use it. Oil is a thick, dark brown or black liquid. So we can use that to make gasoline, kerosene, diesel fuel, a bunch of other different kinds of fuels come out of that. And here's the process. The animals in the ocean die. They're covered with tons of material. And then heat and pressure, again, just like the coal, the lignite to coal, heat and pressure convert oil and natural gas. Now we got another one. Another non-renewable resource, nuclear. It's relatively clean electricity generation. It's the only non-fossil fuel mined from the ground. In other words, we dig it up. That's what it looks like. The waste must be disposed in a safe way. Now we have waste from coal-fired plants, the ash, the stuff coming out of the incinerators. This is relatively clean. We may raise river temperatures 2-3 degrees Fahrenheit. But uranium has a property that the other fuels don't. The waste is radioactive, not for years, for centuries. The spent nuclear fuel, in other words, when the energy is released from the nuclear fuel, we have to replace that. It's kind of like changing a battery. But you can't just throw these things away. You have to store them, and you store them in canisters. And this is what the spent nuclear fuel canister looks like down here. There's not a lot of waste, but it never goes away. Even a low-level waste is dangerous. So we need to find a place to put this where it's going to be safe for centuries. So why is it important to know about non-renewable resources? Most of our energy comes from them. We need to understand how to make them last longer and how to use them wisely. And once they are gone, they are gone. And as they disappear, energy is becoming more and more expensive. There's your lesson in non-renewable resources.